Hello everyone. In this video, we are going to learn one of the application of Gauss Law. We are going to derive the expression of electric field due to infinitely plane sheet charge. Okay, so you can see this is a plane sheet of infinite length. So we have to prove that electric field due to infinitely plane sheet charge is what? E is equal to sigma by 2 epsilon naught. So for this, consider a uniformly charged infinitely plane sheet having the surface charge density sigma. What is surface charge density? Charge acting per unit area is called as what? Surface charge density. Yes or no? Now the direction of electric field, okay, it is what? Radially outward. So you can see one sheet is there. Okay, that Q charge is spread. So electric field will be in which direction? The direction of electric field is what? Radially outward. Yes or no? To find the electric field, we have to imagine a cylindrical Gaussian surface. Okay, we have assumed that a cylindrical Gaussian surface which is covering the sheet. Okay, so we have assumed that there are three surfaces. One is this surface. Okay, this end is there. Okay, another is what? This end 2, 1, 2, and third is what? This curved surface area. Third surface is there. So we have to find the flux through all the three surfaces. Okay, so what is the flux through the surface 1? Flux is equal to what? E into ds into cos theta. Okay, so here electric field will be in which direction? In this direction. Yes or no? Area vector is also in the same direction. So theta is what? 0 degree. Yes or no? So what is the flux due to 1? Okay, let's assume that the cross sectional area of this is A. So we can write E into A into cos 0 is what? 1. So that is a flux 1 is equal to what? E into A. Similarly, what is the flux through the surface 2? Flux through the surface 2 is what? E into ds into cos 0. Okay, here also you can see electric field is in this direction, area vector also in the same direction. So theta is what? 0 degree. Okay, and this area is what? A. So we can write flux 2 is what? E into A. Yes or no? Now what will be the flux through the surface 3, third surface? Now you can see area vector is in this direction, electric field is in this direction. So flux through 3 will be 0. How? Because theta is what? 90 degree, and we know that cos of 90 is equal to how much? 0. So flux through the third surface, that is the curved surface area, is what? 0. Is it clear? Okay, so what is the total flux? Total flux is what? Flux due to one surface, two surface, and third surface. Flux due to one surface is what? EA. Second surface is what? EA. Substitute the value, that is EA plus E into A plus 0, that is what? 2 times of EA. Okay, it is the total flux through the Gaussian surface. Now we know that by Gauss law. Okay, by Gauss law. Okay, what is the total definition of flux? Total flux is what? 1 by epsilon times the charge enclosed by the surface. Let's take equation 2. This as equation 1. First flux I have taken as total flux is what? 2 times of EA, that is 1. And this by Gaussian surface flux is what? Q by epsilon naught times. Now equate 1 is equal to 2. So what we can write 2 times of E into A is equal to what? Q by epsilon naught. As we know that we have assumed that the surface charge density is what? Sigma, that is Q by A. Okay, now so from here what we can write? Q is equal to what? Sigma into A. Okay, so we can write here E is equal to what? Q upon 2, and A will come into the denominator right hand side, into 1 by epsilon naught times. Yes or no? Now substitute the value of Q. What is Q actually? Q is nothing but sigma into A, that is surface charge density into area of cross section. So if you substitute here, you will get E is equal to what? Sigma into A upon 2 times of A into epsilon naught. Now A and A get cancelled. Okay, so we will get the final expression of electric field is what? Sigma by 2 epsilon naught. This is the expression of electric field due to infinite plane sheet, okay, having charge density sigma. I hope you understood these derivations. This derivation may be asked for 3 marks in the board examinations. Please like these videos. Don't forget to share with your friends and subscribe the channel. Thank you.